Welcome to my channel, and welcome back to another video. Today we're going to go through calorific value. You might have seen the previous couple videos. One was on heat conversions, one was on volume conversions, and now we're going to kind of combine those two into what we've referred to as calorific value. So the first thing we should do is, well, what is calorific value? Okay. The definition is it's the amount of heat energy in a given volume. In this case, we're talking about fuel. In this case, we're going to talk about natural gas, but we could be talking about propane or butane. Okay, and this heat energy is released during the combustion of the fuel. So when we talk about natural gas, our starting point, okay, or our original calorific value is 1,000 BTUs per cubic foot. And what we want to do here today is express that in another three ways. Okay, we want to express it in kilowatts per cubic foot. We want to express it in BTUs per cubic meter and kilowatts per cubic meter. Okay, so we're going to take this starting point here, 1,000 BTUs per cubic foot, and we're going to translate it down to these three. Now, we need a couple pieces of information to do this, and that's these guys up there. 1 kilowatt is 3,412 BTUs, and 1 cubic meter is 35.31 cubic feet. And that's the kind of stuff we're talking about in the previous two videos. All right, so here's how we do this. We're going to start here, 1,000 BTUs per cubic foot, and we're going to say, okay, how many kilowatts per cubic foot is that? Now, what you'll notice in this thing is there's two different parts. One is the heat energy, and the other is the volume. Sometimes you're going to change the heat energy, sometimes you're going to change the volume, and sometimes you're going to change both. In this case, the heat energy is changing from BTUs to kilowatts, but the volume is going to stay the exact same. So realistically, all we're doing is saying 1,000 BTUs, how many kilowatts is that? Well, to do that, we come over here. We say, okay, well, we have 1,000 BTUs, and we have 3,412 BTUs per kilowatt. So 1,000 divided by 3,412 is 0.293. So that's another way to express the calorific value of natural gas, 0.293 kilowatts per cubic foot. Now, go to the next one. 1,000 BTUs per cubic foot, how many BTUs is that per cubic meter? Another way to express the calorific value. In this case, the heat energy, the units are the same, BTUs and BTUs. We're changing the volume. We're going from a cubic foot to a cubic meter. Now, this is the part where you have to visualize. You say, well, a cubic meter is a lot larger than a cubic foot. How much larger? Well, it's 35.31 times larger. So if we have 1,000 BTUs in a cubic foot, it would only stand to reason that we would have 35.31 times more energy if we filled up an entire cubic meter. So we would take the 1,000 and multiply it by 35.31. That gives us 35,310 BTUs per cubic meter. All right, that's another way to express the calorific value of natural gas. All three are expressing the calorific value of natural gas. The key between these two here is it's an actual different volume. There's much more stuff here, we can say, much more heat energy. The third one is this, or the last guy, kilowatts per cubic meter. If we were to go from way up here, 1,000 BTUs to kilowatts, we're changing the heat energy. And 1,000 BTUs per cubic foot to how many kilowatts per cubic meter, we're also changing the volume. We're doing both. Now, we can do a little bit of a cheap and easy method. We already know this guy, all right? 0.293 kilowatts per cubic foot. How many kilowatts per cubic meter is that? Well, what we would do is we'd take the 0.293 and we'd multiply it, cubic feet to cubic meter, small to big, by 35.31. Okay? Now the other version, the other way we could do this one, we can do this two different ways. BTUs per cubic meter to kilowatts per cubic meter. The volume is the same, but the way we say the heat energy is different. So we would go 35,310, and we would divide it by 3412. Either method, either way, going from here to here or there to there, we're going to get the same thing. And what we end up with is 10.35 kilowatts per cubic meter. So in the end, we have 4 different ways to express the calorific value of natural gas, and all represent natural gas. All right, thanks for watching, guys. Hope you have a great day. Check out some more of my videos if you want, and we'll see you for the next one. Take care.